Bismillahirrahmanirrahim. This question is October number 23, variant 41, question number 8. A cylinder is made of modeling clay. The modeling clay is an electrical conductor. Figure 8.1 shows a cylinder. This is cross-sectional area. This is the cross-sectional area of the cylinder, and uh, this is the length given. Okay. The cylinder is connected in a circuit. Figure 8.2 shows that the circuit is also include a battery of EMF 9 volt and a resistor P. Resistor P. Okay. Resistor P is 4 ohm. So this is 4 ohm resistor. The current in P is 1.5. So current in the circuit is 1.5 ampere. As the circuit is series, so current will be same everywhere. The magnitude X of the charge, the magnitude x of the charge that flow through the P in 600 seconds. So we can find out the magnitude of the charge by using the equation I is equal to Q divided by T, and Q will be equal to I multiplied by T. So I is given 1.5 and T is given in the question, that is 600. After multiplication, we will get the answer 900 coulomb. The resistance of the cylinder of modeling clay. We need to find out the resistance. As you can see, this circuit is a series circuit. This circuit is a series circuit, so it means this R and this R will be added. Okay, so V is equal to I, and I can write both resistors like this in addition form, because series resistors can be added mathematically we can add them. So I will go with this formula. V is equal to I, and R resistance of the P and resistance of the clay, modeling clay, right? This RC is unknown. RC is the resistance of the clay, that is unknown. So value of V is given, that is 9 volt. 9 volt current value is 1.5. RP is 4 and RC is unknown. Mathematically, when I will solve this equation, I can write 9 divided by 1.5 minus 4 will be equal to RC. 9 divided by 1.6 is equal to 6 minus 4 is equal RC. So this RC will be equal to 2. So the resistance of the modeling clay will be equal to 2 ohm. Okay. The cylinder is removed from the circuit and replaced with a new cylinder made up of same modeling clay. Mean the material will be same, but the shape will be new. Because it's given the new cylinder is twice the length. Mean if the previous cylinder have the length L, then the new cylinder will have a length 2L and half the cross-sectional area. Mean the old cylinder having area A, and the new cylinder area is A by 2, or A by 2, or 1 by 2, A by 2 of the first cylinder. Calculate the time that is now takes for the charge of magnitude x to flow through the resistor P. This question is for the 4 marks. So I will use a method that help you to understand when we make the dimension of the cylinder, then how its resistance change. I think you know well that resistance is directly proportional to length and resistance is inversely proportional to cross-sectional area. If I join these two equations, I can get R is directly proportional to L upon A, and this proportionality sign is removed with a constant, and that constant is resistivity. So R will be equal to resistivity time length over A. This resistivity is the resistance of a particular length of the material. So I will write this equation in terms of resistivity. So resistivity is equal to RA over L. This equation is for the first cylinder that have a length L, area A, and resistance 2 ampere. After making a change, it's very clearly mentioned in the question that the new cylinder is made up of same modeling clay. It means its resistivity is same because material is same. So for the new cylinder, the resistivity. I mark this equation as equation number one, and for the new cylinder, the equation can be written as resistivity is equal to RA over L. Because its material is same, resistivity will be same, so I can write this equation like this. Equation 1 and equation 2, one side of the equation is same, left hand side of the equation is same, so I can compare these equation as R A over L is equal to R A over L. Just to make a difference between these RA over L, I can write R1 area 1 length 1, R2 area 2 length 2. We just have calculated that resistance of the relay before making a change, it was 2, its resistance was 2. So value of resistance will be 2, area will be A, and length was L, right? The new resistance R2 we have to find after making these changes. So now I'm going to replace these changes because the new area is now A by 2. The new area is A by 2, and the new length is given in the question, that is 2L. If few variables can be cancelled, see, this area and area can be cancelled out, this length and this length can be cancelled out. So you have new values remaining in the equation. 2R2 and 2 this 2 is denominator, and this 2 will be multiplied from the top. So we have this equation, R2 over 2 by 2. So after calculation, the new resistance will be 2 times 4, and R2 will be equal to 8 ohm. This R2 is the new resistance of the circuit after making the change. Okay, so if we find out the value of current after this, after making the change, so it means now we have a resistance with double the length. The length of the conductor is double, and cross-sectional area is half. Okay, so with these changes, now the new resistance we have find 8. So I will find out the value of the current in the circuit. So V is equal I into R, and I is equal to V by R. V is given in the circuit, that is 9, and after changes in the circuit, after changing in the modeling clay, the new resistance is 8. So total resistance of the circuit become 12. 9 divided by 12 will be equal to 0.75 ampere. So this is the new current in the circuit. This is the new current in the circuit, right? So with the help of this new current, the charge is already mentioned by the examiner in 600 second. That was before 900. So now we will check like how much this charge 900 coulomb take time to pass through the circuit when the modeling clay conductor is changed. So to find out the value of this time, I will go for this equation. I is equal to Q divided by T, and time will be equal to Q divided by I. So Q we already have, charge we already have, that is 900 coulomb, and the value of current that I just find with calculation after finding the new resistance, then instead of 600 seconds, you will get the time 1200 second, mean that 900 coulomb charge take 1200 seconds to pass through the circuit.